Hi everybody, today we're going to talk about section 7.5, which is applying properties of similar triangles. A little bit more practice with what we've been working on. I know some of the quiz questions gave you guys some trouble, so hopefully today we'll clear that up. I'm really hoping to be back with you on Monday so we can work through some of these together. Okay, so open up to page 17 in your packet. My file shifted a bit, so this should actually be down on page 17. And give these warm-ups a try. If you want, pause the video, see if you can get it set up. Okay, let's give it a try. So first of all, if the two sides are parallel, then the sides are proportional. So if we're looking for MV, I can say x over 8, so this portion over this portion is equal to this portion over 14. Well, I don't know what this portion is, but I can see that the whole thing's 49, so if I subtract 14 from that, that would make this section 35. So I can set x over 8 equal to 35 over 14. And then again, the hard part's getting it set up. Once it's set up, just cross multiply 14x equals 35 times 8. $280, and then just divide by 14 to get 20. And that is the length of MV, so you're done. Remember, sometimes you might be setting x equal to the whole thing, so you might have to subtract or add something, so just be aware of that. Okay, your angle bisector theorem. So if the angle in a triangle is bisected, then the sides are proportionate. So 7x over 5x plus 2 equals the side that's with 7x, 144, over 108. And then again, just cross multiply. I'm going to pause the video so it's not as long. You should cross multiply as well. Okay, when you cross multiply, you should get, I did 7x times 108 first, since it would be a larger number, 756x equals 144 times 5x, which is 720x, and 144 times 2 is 288. All right, we got to get our x's together. I know that the numbers are fairly big, but that's okay. The steps are still the same. So when we subtract the 720x, we're going to end up with 36x equals 288. And then we'll just divide by 288 by 36. And we get 8. Now be careful, it said to find SQ. All right, so we still have some work to do. We're now going to have to substitute in. So we have 56 here, right? 7 times 8. 5 times 8 is 40, plus 2 is 42. So if I want to find SQ, I'm going to have to add those together. We're going to get 98. Kind of a longer problem. Just be aware whether it's asking for X or, to find a certain value. Okay, so a scale drawing is a drawing of an object that is made smaller or larger than the object's actual size. The drawing scale is the ratio of any length in the drawing to the actual length. All right, so it's the drawing to the actual, okay, for your scale. Now, this is used a lot, if you are going to go into architecture. You're not just going to start building something, you're going to come up with a plan. So in that plan, you're going to need a scale so everything works out properly. Okay, so it says the scale for the diagram of the doghouse is 1 inch is equivalent to 3 feet. Find the length of the actual doghouse. Well, this is always your first fraction. We can write a ratio as a fraction instead. And I'm just going to write what it was, inches over feet. This is I call it a guiding fraction, just to help me decide how to set it up. So I had inches over feet. So if I want to figure out the actual, the model is 0.75 over x. So cross multiply, 1 times x is x. 0.75 times 3 0.25. Oops, I was going to say that doesn't seem right. 0.75 times 3, we're not dividing. 2.25, that looks better. And x was in the denominator, we were looking for the actual, so it's your feet. Okay? All right. The next one's a little trickier because it's dealing with feet and inches. So the easiest way to go about something like this is convert them all to the same thing. I would convert everything to inches. All right, so 5 feet 6 inches, or let's start with 5. There's 12 inches in a foot. So this guy's shadow is 60 inches. I'm going to convert everything to inches. So 5 feet is 60 inches plus 6, so he's 66 inches tall. All right, over here, for the flagpole, I'm going to multiply 14 times 12. $168 plus 2 is 170 inches. I'll write it up here so it's easier to see. And now we can easily find the height of our flagpole. So again, it's going to be easier if you convert everything to the same unit. All right, see if you can get your proportions set up. I'm going to pause the video and do the same. Okay, so if you look at what I did, is I took 66, I did the height on top of the person over x, so I did the height of the person over the height of the flagpole, equals the shadow of the person and the shadow of the flagpole. So again, I did the person and the flag. Person's measurements are on top, flag's on the bottom. All right, cross multiply. So we have 60x, then we have 66 times 170. Now, you may have set this up differently. Maybe you did the person's height over shadow equals height over shadow. Either way, it doesn't matter how you set up your proportion. As long as you get the same cross products, you're good to go. So now just divide everything by 60. So the flagpole is 187 inches. Now, if you want to convert that to feet, you could divide it by 12. So it's 15 feet. And then to figure out how many inches it is, we'll do 15 times 12 to see exactly what that is, 180. And so if it's 180, you have to get to 187. It would be 15 feet and 7 inches. So either of those would work. So a little bit of conversion in there too. Okay, let's take a look at a few more examples. If you want, like I said, you can go ahead and try these on your own and then check your answer. Totally fine. The rectangular central chamber of the Lincoln Memorial. I'm going to start there. Rectangular central chamber. So rectangle is 74 feet long and 60 feet wide. Make a scale drawing of the chamber using a scale of 1 inch is 20 feet. Okay, so we actually got to set up a couple different proportions here. So we want to do one for the length and one for the width. This is always going to be your first fraction. So 1 inch is 20 feet. Well, we're dealing with the actual, so the 74, when I set it up, will be on the bottom. So that's how we'll figure out the length. And then to figure out the width, we'll set up a second proportion. 1 over 20 equals x over 60. All right, and then we can just cross multiply. So 20x equals 74. Divide by 20. 74 divided by 20 is 3.7 inches. Because again, we're taking the actual and making a replica of it. And then for our width, 20 times x is 20x. 1 times 60 is 60. Divide both sides by 20. X equals 3. So make a scale drawing of the floor of the chamber using a scale of 1 inch is 20 feet. There you go. There's your answer. 3.7 inches by 3 inches. Okay. In the diagram, points D and E are on AB and CB respectively, such that AC and DE are parallel. Good to know, because then we have that proportion. All right, so AD is 24. DB is 12. And DE is 4. Find the length of AC. Okay, for something like this, we're dealing with two similar triangles that are overlapping. All right, so we have the little triangle. I'm just going to label B, D, E. Again, it helps if you draw it out. With some of these questions, if you're just trying to set it up and not taking the time to draw it out, it does make it more complicated. All right, for a bigger triangle, it's triangle ABC. We're looking for AC. The length of AB would be this whole thing. So in this case, it's not 12 or 24, it's going to be 36. So now it might be easy to see what to do. So I'm going to start with AC. DE matches that. So I'm going to do x over 4 equals, since I started with AC, I got to start with 36 over 12. And you may see the relationship right now. You're dividing by 3. So x is going to be 12, but let's just cross multiply and see. 12x equals 36 times 4. 144. And when you divide that by 12, you do get 12. So the length of AC is 12. Okay? So again, it is helpful to draw out those triangles. Take the time to do it. The last thing I want to talk to you about today is, we've been looking at the sides being proportionate. Well, there's also a ratio to look at with area and perimeter. So we're going to talk about that today. So it tells us these triangles are similar. The ratio of the sides, because it's starting with ABC, it's 5 to 10, which simplifies to 1/2. All right, if you look at the others, 8 to 4, 4 to 8, went the wrong way. 4 to 8 and 3 to 6, they all simplify to 1/2. So the ratio of sides is 1/2. All right, well, if we found the perimeter of each one, so the perimeter of this guy would be 5 plus 4 is 9, plus 3 is 12. The perimeter of this guy is 10 and 8 is 18, plus 6 is 24. The ratio of the perimeter is also 1/2. Okay, so these are the same. However, the ratio of area is a little bit different. Now, the area for a triangle, 1/2 base times height, or base times height divided by 2. Your base and your height, remember, are perpendicular. So 4 times 3 is 12, divided by 2 is 6 for this area. The area for this triangle would be 8 times 6, which is 48, divided by 2 is 24. Now we want to simplify that. That does not simplify to 1/2. 6 divided by 24 is 0.25, math enter, 1/4. So basically what happened was since you're multiplying, you're squaring something, the the ratio of the area is always this squared. All right, so that's something you'll want to remember. Sometimes you can do the math to figure it out, sometimes you can't. But the ratio of the perimeter and the sides are the same. The ratio of the area, you square it. So I put that in the next page. This may be on page 18 for you, but so the similarity ratio, if it's A over B, it's the same for the perimeter, and for the area it would be that squared. You definitely need to memorize that. So let's look at a couple examples with no picture, but we can still figure this out using this. So if the sides have the ratio 5 to 6, that's your similarity ratio. The perimeter ratio is also 5 to 6. And the area ratio would be 5 to 6 squared. So it would be 25 over 36. Okay, this one's a little different. The area has a ratio of 9 to 25. So if you want to find the sides and perimeter, instead of squaring it, you're going to take the square root. It's going to be 3/5 for both. All right, let's look at just a couple more examples, and then we'll call it. Okay, A, B, C, and D, E, F are given. Find the perimeter, and if the perimeter is 42 and 96 for D, E, F, then we're going to figure some things out. Okay, let's draw a picture. We have two triangles, ABC and DEF. And I'm writing them in the same position because A matches D, B matches E, C matches F. Let's label what it gave us. BC is 4. EF is 12. All right. And then it tells us the perimeter is 42 and the area is 96 for DEF. We'll worry about the units at the end. Okay. So the first thing, it says find the perimeter. All right. Well, first of all, let's figure out what the similarity ratio is. 4 to 12 equals 1/3. Okay? How did I do that? I just simplified the fraction. 4 goes into both of those. 4 divided by 12. Math, enter, enter. 1/3. Okay. So let's start with the perimeter. I'm going to take this 1/3, kind of like when we did the Lincoln example. Okay? We set up the two different proportions. We're going to do the same thing. So the perimeter has the same ratio, 1 to 3. So I can do x over 42, cross multiply. 3x equals 42, divide by 3. So the perimeter for AC is going to be 14 millimeters, which makes sense because if you do 14 divided by 42, math, enter, enter, it simplifies to 1/3, the same thing. Okay? Now for area, remember it's not 1/3, we have to square it. So we set it equal to 1/9, right? 1 times 1 is 1, 3 times 3 is 9. The area of DEF is 96, so that goes down here. So 9 times x is 9x. 1 times 96 is 96. Divide both sides by 9. 10.6 repeating. It doesn't say to round, but we'll just round to 10.7 square millimeters. All right, so a little tricky with those, but just remember perimeter has the same ratio, area, you square it. All right, one last example, and then I'll leave you to the practice, which we will go over on Monday. Hopefully I'm here Monday. If not, I'll put up instructions on what to do. Okay, so again, you can see that the sides are given. So let's figure out the similarity ratio first. 6.5 over 13. Okay. All right. So if we want to find the perimeter of ABC, we're going to just leave the 6.5 over 13. And since it's the perimeter of the second triangle, we're going to put that in the bottom. So we're going to do the perimeter first. So 13x equals 54 times 6.5. $351. And then we'll just divide by 13. 27. So the perimeter of triangle ABC is 27 inches. There's your first one. Now the area, we're going to have to do 6.5 over 13 squared. Remember, because we're not just going to set it equal to the same ratio, we have to square it. So I'll put the 126 here because that's the area, but let's figure out what our similarity ratio is for the area. So 6.5 squared and 13 squared. So it's going to be 42.25 over 169. Again, you had to square it. Don't worry about how big the numbers are. It'll all work out. So 169x equals 126 times 42.5. I can just go up in the calculator and hit enter or type it in. And then divide by 169. $31.5 is your area. So up here, 31.5. Since it's area, it's inches squared, square inches. That's how many little 1 by 1 squares would fit in there. Okay, so your next assignment, which we will do together on Monday, you don't have to do this for homework tonight. You're welcome to start it if you want. Begins on page 20. It's the 7-5 practice. And you'll also do page 21 with some mixed review. Like I said, if I am back on Monday, we'll walk through this together and go over stuff. If for any reason I have to be out longer, I will put up a video walking you through this and moving on to the next section. I hope you all had a great week. Please let me know if you have any questions at all. I'm happy to help.